We have talked about acids and bases, so now we're going to talk about the pH concept. pH scale is going to be used to express the hydrogen ion concentration. So when you see these square brackets, that means the concentration. So it's the concentration of whatever is in those square brackets. So how much of this thing do you have? pH is going to range from 0 to 14, with 0 through 6 being acidic, 7 is neutral, and 8 to 14 is basic. In this class, there are no negative pH values. It's only going to go from 0 to 14. If we look at this chart, we notice that over here we have the hydrogen ion concentration, and here is our pH value. So on the acidic end, okay, our hydrogen ion concentration is going to be higher than at our basic end. There's going to be more hydrogens present in the solution if the solution is acidic. Notice that the pH value is equal to the positive value of the exponent here. So as long as it's at a base 10, and there's not another value there, pH is going to equal the positive exponent on your hydrogen ion concentration. Again, acids have more hydrogens present, so the hydrogen ion concentration is going to be higher at that end than at the basic end, where we have a lower pH. So when you're solving for pH, the pH of a solution is going to equal the negative logarithm of the hydrogen ion concentration. So pH equals the negative logarithm of your hydrogen ion concentration. For a neutral solution, your hydrogen ion concentration is going to equal 1 times 10 to the negative 7. So if you take the pH, or to find the pH, take the negative log of 1 times 10 to the negative 7. Make sure you're using your EE key here to cut down on your exponent, your parentheses use. Also, there is no unit for pH, so make sure you're putting that pH equals whatever. So in this case, you should have found 7 to be your answer. In order to find the hydrogen concentration of the solution, so you're starting with the pH, and they want to know what the concentration of the solution was. You're going to take 10, raise it to the negative power of whatever the pH is. So what is the pH of a solution with a hydrogen concentration of 1 times 10 to the negative 4? So you're going to do pH equals negative log 1 times 10 to the negative 4. When you type that in your calculator, you should get your answer of 4. Then they want you to find the hydrogen concentration of a solution with a pH of 6.5. So you're going to find your hydrogen ion concentration is equal to 10 to the negative whatever your pH is, in this case 6.5. So if you do 10 raised to negative 6.5, you should come out with 3.2 times 10 to the negative 7. If you want to check your work, since these are opposites of each other, you can take this hydrogen concentration, plug it into the original pH equation up here, negative log, and you should get 6.5 for your answer. That's to check your work. POH. So OH is a hydroxide, so the POH of a solution is also going to be not a negative logarithm, but instead of using the hydrogen concentration, you're going to use the hydroxide concentration. So POH is going to be referring more to basic solutions. Hydroxides indicate that it is a base. So the POH is going to equal the negative log of the hydroxide concentration. And just like finding the hydrogen concentration, to find the hydroxide concentration, you're going to take the base 10 of the POH, so 10 to the negative whatever your POH is, and that'll allow you to find the concentration of the solution. Your POH scale is going to be opposite of your pH scale. Since this is measuring how much hydroxide is present in the solution, it's going to be backwards. If you have an acidic solution, you're not going to have a lot of hydroxides floating around. So your scale is still going to go from 0 to 14, but 0 to 6 is going to be basic, 7 is still neutral, and 8 to 14 is now going to be acidic. You're going to have less hydroxides in that solution. If you notice this pH scale comparison chart, here we have our pH, and over here is our POH. If your pH is 0, your POH is 14. If your pH is 4, your POH is 10. If your pH is 10, your POH is 4. If you add these two numbers up, each time you're going to get 14, and that goes for any of them. 6 and 8 equals 14. So because these two scales are opposite to each other, every time you decrease your hydrogen concentration, you are increasing the hydroxide concentration. And they're always going to remain equal to each other. If you add them up, they're always going to equal 14. So if you know either the pH or the POH, you can solve for the other because they're both going to add up to 14. So you would have to take whichever one you're looking for, subtract the other from 14, and that would give you your answer. So the pH plus the POH is always going to equal 14. So let's say ammonia has a hydroxide concentration of 4.3 times 10 to the negative third molar. They want us to calculate the pH and the POH. Because they gave us a hydroxide concentration, we're going to be solving for POH first. So POH is going to equal negative log, whatever your concentration is. In this case, it's 4.3 times 10 to the negative third. Negative log 4.3, use your EE key, negative 3, and we're going to get 2.4 is our POH. Since we started with the hydroxide concentration here, you're going to have to find the POH first. To find the pH, you're going to use our rule that pH plus POH equals 14. So if we have our POH, we need our pH. You can subtract the POH from both sides so that you're left with pH. So 14 minus what you found your POH to be is 2.4. 14 minus 2.4 is 11.6. We can round that to 12. So 12 is going to be our pH.